In this video, I'm going to go over how to write out chemical formula of molecular compound and also name them as well. So let's take a look at what is molecular compound. Okay, so molecular compound are going to be the combination between nonmetals and nonmetals. So there's not much, right? So as you see in the previous video, there's only a small group of nonmetals. So note that the name is going to be similar to what we did before with the ionic compound. You are going to name two elements. One, the first name will not change. The second name will change. For example, if you combine between, like, let's say N and O, for example, the name of the first element will not change. Similar to the metal that we looked at earlier, right, would be nitrogen. But the second one, the name will change. It will ending with "ide." So just know that it's pretty simple. So the only thing that you are going to add into the naming of molecular compound is you need to indicate how many of each of the element within the compound, because if you're looking at molecular compound, okay, so we will see that molecular compound can have various combination, such as N2O versus N2O5, or if you're looking at in terms of carbon, right? So we have carbon monoxide, carbon dioxide, and they are different. Okay, so which is not the same as ionic compound, because ionic compound we represent them with the formula unit. So therefore, we are going to represent them always going to be the smallest, simplest ratio. However, with the molecular compound, the number of atoms within the molecule can vary, okay, because these type of molecules are discrete, okay, so they come as a discrete amount, so we would know exactly how many of them, so we have to specify how many, which one are we talking about, right? So if you're looking at this one versus this one, how can we tell that they are different, right? So what are the names that indicate that they are different? So that's what we're gonna take a look at today, okay? So the name of this is pretty simple. So again, we have two elements. The first one will not change. The second one will change to I. The only thing we need to include would be the prefix. Okay, so this is going to be the same prefix that we use with water. Okay, so the number of water that we indicate for the ionic compound is going to be the same prefix that we use here, because we use prefix only for molecular compound. Only molecular compound that will use prefixes. Okay, so these prefixes right here will tell us about the number of atoms of that element. Okay, so for example, the first prefix will tell you about how many of the first element. This prefix will tell you about how many of the second element. Okay, so let's take a look at example. Okay, so these are the example of prefixes, right? Mono, di, tri, tetra, and so on. And then the second element, just know that it always have to change to I. So which I already mentioned before, right? Hydrogen would be hydride, carbide, nitride, oxide, fluoride, and so on. Okay, so we already see that. So let's take a look at example. Okay, so example would be Cl2O3. So this is molecular compound, not ionic. So therefore, I'm going to use prefix. Okay, so again, prefixes used only with molecular compound, such as this one or water. So what is the name of this? Okay, so again, we're gonna use the prefix to describe the first element. So 2 chlorine, it would be dichlorine. And then 3 oxygen, it would be tri. But because oxygen is the second element, so we're gonna change to I. So it would be trioxide. Okay. Second one, N2O. Again, 2 nitrogen would be dinitrogen, and then we have only 1 oxygen. So the prefix for one would be mono. So it's monoxide, but you actually fuse the vowel together, so it would be monoxide. Okay. And next one, when you have the first element contain just one atom, this one, you are going to drop the word mono. Okay, so instead of using monocarbon, we are going to drop the word mono for the first prefix. We do not drop the mono for the second element. Okay, so only the first element. So the name of this would be carbon. Second element would be monoxide or monoxide. Okay, so you fuse the vowel. Okay, go ahead. I'm going to let you pause your video real quick and go ahead, complete these 3 examples right here, and then resume it when you are ready. Now let's check your work. Okay, so this one would be diboron hexahydride, right? Hydrogen changing to I hydride. This one would be phosphorus. We drop the first mono, trichloride. Okay. Next one, 4 is tetra. P is phosphorus. And then deca, sulfur, we change to I, so it would be sulfide. So tetra phosphorus deca sulfide. All right, check your work. Okay, so I'm gonna go ahead. Okay, so this example right here will allow you to do both. Okay, so you are going to learn how to name it, and then with the name, you should be able to find out the chemical formula as well. Okay, so I'm gonna go ahead, give you a few minutes here. So let's pause the video now, complete A to G. When you are ready, resume the video again. Okay. All right, 1A, xenon and oxygen 3. So this name would be xenon trioxide. Hey, Ami, wait a second. Xenon is part of noble gases. So how come xenon actually form compound? Okay, so under extreme conditions such as high pressure and high temperature, the noble gases have like a large size of atom. They can undergo chemical reaction to form compound. Okay, so but it's have to be at like a high condition, like a extreme condition such as like high pressure and high temperature, okay, to cause them to form bonds. Second one, diamine 2 iodized I, right? Penta is 5, so therefore the chemical formula would be I2O5. C, the name of this would be monochlorine, except that we are dropping the first mono, so it would be chlorine monoxide. Okay, so instead of having mono in front, would be chlorine monoxide. Next one, sulfur hexafluoride. Sulfur is S. So in this case, it doesn't specify the word mono, so it's implied that only one sulfur, so it would be one sulfur with 6 fluorine. Same thing with phosphorus as well. It would be P and then 3 of the bromine. Okay. Next one is dinitrogen tetroxide. Again, tetra and oxide, you fuse the vowel together, so it would be tetroxide. And last one would be diphosphorus pentasulfide. All right, last part of naming of molecular compound, which is actually going to be, might be the most confusing part, is the naming of acid. Acid classified as molecular compound because acid contain all nonmetals. In order for us to recognize what is the acid, you are going to recognize by having hydrogen written first and also include the aqueous as well. Okay, so if hydrogen written first and it doesn't follow by AQ, that is not an acid. The name would be the same as what we did before. Okay, so what is an acid exactly? So acid is the compound that contains hydrogen that can be donated in water, and this amount of hydrogen would dictate acidity of the solution. Okay, so that's pretty much what it is. Example of this would be hydrogen written first, followed by another nonmetal X. Okay, so X can be anything. It can be like chlorine, bromine, or even the group of polyatomic ion, right? NO3, for example. And again, because of, by definition, acid can give off hydrogen. So this hydrogen right here, H plus, is going to be given off. And this H plus right here, the amount of this H plus right here, going to dictate the pH of the solution. The name of this H plus, we call it hydrogen ions, and the most common name is what we call proton. What do you call proton, Ami? Well, if you think about hydrogen neutral atom, right? So hydrogen neutral atom contain one proton in the nucleus, contain no neutron for hydrogen. And then if you're looking at in terms of electrons, this is the most common isotope. Okay, so this isotope doesn't have any neutron. So for the neutral hydrogen atom, it's got one proton and one electrons. So when hydrogen become plus, is indicate that it's already lost these electrons. So therefore, the only thing available is the proton inside the nucleus. So that's why the name can be called proton, just because of that. Okay. All right. So generally, this is how you recognize it. Again, hydrogen written first, followed by another nonmetals. You might see other exception when we're looking at organic acid. So some of the organic acid, you're not going to see hydrogen written first. I'm going to talk to you about that later. Okay, so how you recognize them. But in this case, just note that for this class, I'm going to always indicate hydrogen written first, including the AQ or aqueous. Okay, so in order for you to recognize that this is an acid. Okay, so when you go to another higher level of chem, you will see that sometimes hydrogen doesn't have to be written first. Okay, so according to the structure. Okay, so with that being said, I'm going to go ahead, look at two different type of acid. One is binary acid, which means it contains only two elements, which is going to be HX. So again, hydrogen first, followed by any X, right? Any non-metals. So note that is need AQ as well. Second one, oxy acid. Oxy, the name implies, going to contain oxygen. Is the acid that contains oxygen. So the generic formula would be HX. So X can be any other nonmetal, but this nonmetal include oxygen as well. So therefore, if you think about what are the nonmetal that include oxygen, these are going to be the polyatomic ion, such as nitrate, for example, like carbonate, for example. Okay, so those are the like that's represent X, that's represent O, right? So again, this will have to be in aqueous as well. Okay, so the name of these two will not be the same. So I'm going to go ahead, give you the name real quick, so that way you can see it. When you see it again, it's easier for you to understand. When you name binary acid, the name of binary acid would start with the word hydro. Hydro. And then followed by the name of X. I don't know what is the name of X is, but the name of X, instead of ending with I, similar to what we did before, like fluoride, chloride, you are going to change those I to end with ic. So for example, chloric, bromic, and so on. This is gonna end in with ic. And then you're gonna ending this name with the word acid. So it would be hydrochloric acid and follow, and then so on. However, with hydroxy acid, because hydroxy acid, you can have polyatomic ion either ending with 8 or 8. The name of oxy acid would differentiate by that. Okay, so by the original name of polyatomic ion. So note that oxy acid would not have the word hydro. So no hydro. Okay, so you're not going to include hydro at all. The name would just come from the name of the polyatomic ion. Okay, so for example, if it's ending with ase, such as nitrate, all you have to do is you are going to change ase to ic, and then followed by the word acid. Okay, so you change ate to ic, followed by acid. For example, nitrate, you change it to nitric, and then followed by acid. And then if the name is ending with "ite," you change to "us" and then followed by the word acid. Okay, so the name would be nitrite, right? Would be nitrous acid, for example. Okay, so that's kind of like an overview of the difference between these two. Okay, so one is with hydro, the other is without hydro. If the name is without hydro, it's going to contain oxygen with it. Okay. All right, so let's take a look at the naming of binary acid first. Okay, so it's only two. So I'm going to combine this H with another nonmetal X. So what are the X? So these are the X. Okay, so I'm going to call this X monoatomic anion because it's only one anion. Okay, so what I'm going to do is I'm going to write out corresponding acid. Remember, H in an acid is always be H plus. Okay, so this is an acid H plus. This H plus in water, that's why it's got like H plus right here. You probably notice that if I combine H plus together with any of these anion, I need to make sure that they have, what do you call it, the charts have to be balanced. Okay, so what I'm going to do is that if I put this H plus or proton together with this fluoride, the corresponding acid would be HF. And notice that you need to also include aqueous as well. Okay. The name of this acid going to be, remember, like the binary acid would start with hydro. The name would be hydro. Fluoride, we're going to change I to ic. So it's going to be hydrofluoric. And then ending with the word acid. Okay, so we're going to change all of this anion I to ic and then followed by acid. For HCl, okay, so because it's 1-to-1, so it will be just HCl. Don't forget AQ, okay, so aqueous. The name of this, because it's no oxygen, it's just HCl, so the name would include with hydro, and then followed by so chloride, change I to ic would be chloric, and then followed by acid. So the next one, HBr, it need to include AQ. Okay, so without AQ, it's not acid. It's going to this compound behave as an acid only in water. That's what it means. That's what the aqueous mean. So the name of this would be hydrobromic acid. HI would be hydroiodic acid. Again, it need to include AQ. So let's try to do one more. Okay, so I'm just gonna do AQ here real quick. What about the combination between sulfur and hydrogen then? What would be the name of this acid, or what is the corresponding acid of this? Okay, so corresponding acid of this would be H, because sulfur is 2-, so we need 2 of H, and then with the S, the name of this acid would be hydrosulfuric acid. Okay, so sulfide, right? Change to sulfuric acid. Okay. And this would be an acid, so I have to have an AQ. All right, so now what about those that contain polyatomic ion? Okay, so I'm going to go ahead, give you the corresponding acid to all of these so that way you can see the pattern of it. Okay, so again, I'm going to combine H plus to all of these anion. Okay, so nitrate is -3, sorry, -1. Okay, so therefore in this case, it's just 1-to-1, so it would be HNO3 aqueous. The name of this, if it's oxy acid, you are going to exclude the word hydro. So the name of this would just be the name of the nitrate, but changing it to ic, followed by acid. So the name would be nitric acid. Nitrite, the corresponding acid would be HNO2, aqueous again. If it's the name is ite, you're gonna change to us and then ending with acid, so it would be nitrous acid. Sulfate, because we have 2- here, so you need 2 hydrogen per 1 sulfate. The name of this is gonna be without hydro. Okay, so the name would be oops, sorry. So the name would be, so I'm going to include aqueous first. The name of this would be, you actually have to go back to the original sulfur. Okay, so it would be sulfuric acid. Okay, so again, it's ending with A, so that's why we're going to have the word ic in the name. What about sulfite? Sulfite would be aqueous, so it would be sulfurous acid. Okay, so again, the take-home message of this would be, if it's ending with A, change to ic. If it's ending with ice, you are going to ending with us. What about phosphate? So phosphate is 3-, so we need 3 of the hydrogen, so it would be H subscript 3 phosphate here. So the name would be phosphate ending with 8, so therefore the name would ending with ic. Okay, so it would be phosphoric acid. For carbonate, it would be H2CO. Oops, sorry, I'm going to go ahead. So it would be H2CO3 with the AQ parenthesis. The name of this would be carbonic acid. Now, bicarbonate. Okay, so bicarbonate already have 1 hydrogen. So therefore, in this case, the chemical formula would contain 2 hydrogen. Okay, so I'm just gonna erase that. Okay, you probably notice that carbonic acid, if you're looking at this, is have the same chemical formula as the hydrogen with the bicarbonate, right? So therefore, in this case, the name of this would be the same, carbonic acid. You might wonder, why is that? Why carbonic acid can yield both of them? Okay, so when you are learning about acid in Chem 123, you will see that carbonic acid, when they're giving off hydrogen or proton, they are going to do stepwise. The first step, when it's give off the first hydrogen, is going to yield bicarbonate. And then bicarbonate can give off another hydrogen to yield carbonate ions. Okay, so it's just the stepwise process of acid dissociation. Okay. Acetic acid. Okay, so acetic acid, you just add one hydrogen to it, and then followed by AQ. Okay, so one thing I want to talk about acetic acid is that there are several ways to write out acetic acid. One is this way that you see here. The second one, sometimes people will combine represent carbonic acid in the most what do you call, like, condensed form. So another way that people write carbonic acid would be C2H3O2 with the negative charge. So if you see this version, just know that it's also represent carbonic as well. But what I'm going to do on exam, I'm just going to stick with this one, okay? So that way you recognize one. This one is the most condensed form. It doesn't actually tell us anything much. The most, so this is like what the form that people use in like general chemistry. But when you go into much more like advanced chem, you're going to see that hydrogen now would not be written in the front. You are going to see acetic acid written as CH3CO2 with the hydrogen at the end. This form right here is going to tell you about the location of where hydrogen actually bonded to. It actually doesn't bond to carbon, it's actually bond to oxygen in this case. Okay, so we're gonna learn about the structure more, and I will let you know more about this. But this is another form of acetic acid. Okay, so it's the CH3CO2H. Sometimes people expand this O2 to CH3COOH. So all of these represent the same acetic acid. Okay, so these two might be the most common form right here. But on exam, I'm going to make sure that you understand hydrogen written first for your easy recognition. So I'm going to put hydrogen written first. Okay. All right, so again, this is acetate. So the name would be acetic acid. Okay, so the name would be acetic acid. Next one, same thing what you see before. All of these contain -1 charges. So therefore, it's going to be just one hydrogen per each of those. Just make sure that you include the aqueous though. So AQ, the name would be perchloric acid. Chlorate would be chloric acid. Chloride would be chlorous acid. Hypochlorite would be hypochlorous acid. Okay, so all of these would contain AQ, AQ, and AQ. All right, now let's take a look at example. Okay, example of this again, when you are looking at an acid. Okay, so I'm gonna walk you through this because I think acid might be the most confusing thing. When you write out and when you the name contain acid, go ahead, write out hydrogen first. Hydrogen will always have to come first, and it's also going to ending with AQ. So go ahead, write that out. If you don't know how to write out chemical formula, if you just give me these two, you are going to get some partial credit here. Okay, so now carbonic acid. This acid doesn't contain the word hydro. Because it doesn't contain the word hydro, I'm going to look up the list of polyatomic ion. The list of polyatomic ion that closest to the word carbonic is carbonate. So I'm going to go ahead, write out carbonate. Carbonate is CO3 2-. So therefore, in order for me to combine with proton H plus hydrogen ion, I need 2 of the hydrogen ion, okay, per 1 carbonate. So therefore, carbonic acid is going to be this chemical formula right here. Next one, H2S. Okay, so this acid, how do I know it's acid? Hydrogen written first with the AQ. So I'm going to write out an acid. Okay, so if you give me the word acid, you already get some partial credit here. Now, what would be the name? The name of this acid going to start with the word hydro. because it doesn't contain oxygen. Okay, so I'm gonna go ahead, let's do hydro. Hydro what? You are going to name this X right here, right, which is the sulfur. So hydro, sulfur would be sulfuric, you're ending with ic. Okay, so it would be sulfuric acid. Now, next one, you probably recognize the difference between B and C is the oxygen. If you have oxygen, this is going to be the polyatomic ion. We don't use the word hydro. So what we're going to look at is we're going to look at the name of SO4. SO4 2 minus is sulfate, is ending with 8. So we can exclude hydro. So the name of this would be sulfuric, and then followed by acid. Okay, I'm going to go ahead, let you complete D, E, and F, and G. Okay, so let's pause the video now, complete these 4. When you are ready, resume the video again. All right, let's take a look at the next one. Okay, so this one contains no oxygen, so you need to use the word hydro. So the name would be hydrobromic acid. E doesn't have the word hydro, so therefore this is gonna have to come with oxygen. So you need to look at the list of polyatomic ion. Per iodic, so iodate is IO3, right? So per would be 4. So this is IO4 minus. So therefore, the chemical formula would be HiO4 with the aqueous. Hypochlorous. Okay, so this one is ending with us, so it's gonna come from the ite, right? So in this case, come from hypochlorite. So it would be ClO minus. So the acid would be H, it would be 1-to-1, it would be HClO with the aqueous. Next one, hydrogen written first with a whole bunch of stuff. So this whole bunch of stuff is what we call polyatomic ion. So therefore, you're gonna look at the list of polyatomic ion. This is acetate. So therefore, the name of this will not contain the word hydro. The name would be acetic acid. Okay, so polyatomic ions, acid that come from that will not have the word hydro. If the acid contain no oxygen, then you're gonna include the word hydro. Okay, so that's the take-home message. All right, so what I'm gonna do is that I'm gonna let you, oops, actually that's not, would be Canvas. Okay, so what I'm gonna do is that I'm going to let you go ahead. Okay, so finish this DIY problem. Okay, so first off, you will need to determine whether it's molecular or ionic compound. Once you know what type of compound, then you can name them based on that. Okay, so you can name them based on what we just learned in chapter 5.5 and also this video as well. You probably notice that this is going to be very similar to the exam because you are going to be given everything mixed together. Okay, so both ionic compound and molecular compound. So what you're gonna do first, so let me actually like go over like a couple example with you. So what you're gonna do first is you are going to go ahead, figure it out first whether they are ionic compound or molecular compound, and then name them based on the system that we learned. The first one is ionic compound. So for ionic compound, we will not use prefixes. So this one will not have prefixes. Okay, so the name of this depend on the metal. So this is the main group element. Perfect. This is going to be strontium. Do I need Roman numeral? No, right? Because this is main group element has a fixed charge. Followed by the next one, nitrogen. So one element, we're going to ending this name to I. So this would be nitride, for example. That makes sense? Second one, this one is molecular compound. How do I know? Well, it's got non-metals and non-metals, so this is molecular compound. Molecular compound, you need to use prefixes, so therefore the name would be disulfur, right? We don't change the first one, we change the second element, and then the second one would be dichloride, for example. You keep doing this, okay? So you're gonna determine whether they are ionic compound versus molecular compound first before you name them. Same thing with the acid as well. If they are molecular compound, have the hydrogen written first with the aqueous, that is the acid. The name would be follow with the acid that we just learned. Okay. All right. Again, if you have any questions after you finish this, just make sure that you come talk to me after class. Okay. Oh, one more thing I forgot to mention is the last problem on page 94. Okay, so you can actually ignore this one because we have not covered this one yet. This is going to be part of chapter 7. Okay, and then this is everything about this chemical formula that we just learned. Okay, so both ionic and also molecular compound as well.